Stammers remove morphological affixes from words, leaving only the word stem. A stemming algorithm reduces the words, and the stems are created by removing the suffixes or prefixes used with the word. For example, the stem of eating, eaten, becomes eat, and the stem of pythoning, pythonista, becomes python.
Hi, after this animation, let's have some FaceTime. Let me explain a little bit about lemmatization, stemming, pardon. Why I talked about lemmatization, why I remembered lemmatization, because lemmatization and stemming is the same, that's why I'm confused sometimes. Well, anyway, we talk about lemmatization in the next class, I promise. Lemmatization and stemming almost the same. There is very little difference. We talk about it in the next class. Well, when it comes to the stemming, stemming is all about grouping, or let's say bringing the group of words. What's the group of words? I'm referring to do, does, doing, done. These group of taking this group of words to what? To the root, to the stem. Stem means root. You know, language, the dictionary we use, or let's take the list of the vocabulary, the list of the words in our vocabulary. The root of these words we are consuming, driven from other languages. So the root of them may not exist in English language, for example. Some of the words root may not exist. So, but we're consuming those languages. So stemming is all about word normalization, let's say. Using Nltk, we normalize the words. Well, this word normalization or text normalization, whatever, it doesn't matter, whatever we call it, normalization. So, when it comes to its history, the algorithm of stemming, lemmatization, the algorithm of them, have been being developed since 1960. Yes. It's interesting. It sounds interesting. It's not new. We are new in this field. Actually, these bodies, so-called stemming, lemmatization, even artificial intelligence. People today think that artificial intelligence is a new thing. No, excuse me, it's not new. For example, the age of artificial intelligence or the algorithm of the stemming lemmatization, their age is, they are older than my mom, actually. They're old enough. Their age is more than half century. So these are not new. The algorithm of stemming and lemmatization, or different kinds of algorithms we know, they are not new. They are old enough. So when it comes to this, the algorithm, let's say, the algorithm of stemming and lemmatization have been being developed since 1960. So, and it's an interesting fact, right? And I think so, at least. And what I was going to say. In the next class, we talk about a little bit about the difference of stemming lemmatization. These are almost the same thing. By the way, as for the definition of stemming or lemmatization in the dictionary, that, for example, it says that, and it's right definition, by the way, lemmatization or stemming is the process of, let's say, is the process of inflection in words to their stems, like this. And you know what? It's the right. When it comes to this inflection, it's inflection. It's a process of inflection in words to their stems. Actually, when it comes to inflection, it's all about modification of word. For example, what kind of word? Any kind of word. Word can be it can be tense. For example, do, does, done, doing. Right? It's inflecting. Modifying the word. So it's the modification of a word, or it can be, for example, number. For example, baby, babies, cat, cats, car, cars, etc. Child, children. So see, child is the root, children. So, yeah, right. If you look through the definitions through as googling, that there are good definitions. So let's dive into the codes.
First, let's write today's tutoring video's topic. It's stemming words with Nltk. So we are going to stem the words. So let's first import Nltk packages. First step is importing very important packages. These are Nltk packages. Wait, Nltk is lowercase. Stem import porter stammer. So we need stammer porter stammer. We need stammer, and then we have to tokenize the text data. So Nltk tokenize import send tokenize, and then word tokenize. So actually we are going to tokenize words just in case I. Next one is that we have to create text data because we have not data. If we have, usually we work with ready-made data. I mean that's kept in different kinds of Word formats, Excel format, etc. But we have not yet, so we have to create ourselves. I'm a Pythonist. I'm a Pythoning the world. It is very necessary to be Pythonly. It must be BE, I know, but I want to leave this error here. Let's see how this calculator, how this machine, how the algorithm of Porter Stammer deals with it. Actually, it doesn't care about the semantic meaning, but let's leave it there. I want to create challenge for the machine. So we have text data, we have tokenizer function, Porter Stammer of Nltk. So let's create a variable. It will be easier to use if we assign this kind of function into shorter order, so it will be easier later for us to reuse. Then what do we need else? We have to tokenize the text data, right? So let's take the word tokenize function of Nltk package and tokenize what? Tokenize this text we created, text data. So let's assign it to example lexicon unit, let's say, and we can use it for stemming now. Why? Because it is already tokenized. So example lexicon unit, it's assigned. The tokenized data are assigned to example lexicon unit. So for unit and example lexicon, we create for loop so that we can see one by one. I want to show you one by one how it stems. So it's going to stem the tokenized word. So now we see we are going to stem the text data. So you see, Python is the Python necessary I instead of Y. It stems like this. Pythoning became Python. Python is the stem of Python. Python is the, it says, so Pythoning, Pythonit, etc. The stem of it, Python. And in the next classes maybe we see how we can extract the limitize. In limitizing, it's a little bit different than stemming. So let's leave this limitization topic to the next class. And that's for it now. Bye bye. See you next time, worlds. So let's create a function. I'm repeating creating function and again. In upcoming 2 or 3 videos, I will repeat creating function. Why? Because it will be easier to you to remember. Yeah, let's define function stammer. Stammer engine. So we need an argument, one argument. So let's take this one for now, and let's put it here, and let's take care of the indentation. They must be inside of function, and that's all. Let's call this function. Let's print this function. Okay, stammer engine. What do we need? We need one argument, this argument. We need this argument. Let's print. Wait a moment. Actually, we can name it as whatever we want. So let me show you now. Example 1, for example. One moment. So let's see. And now you see that we can put any kind of data instead of this argument, and you see the result is the same. That's why it's called customizable. Functions are customizable, and I highly suggest, not just me, it's suggested, it's highly recommended to create function. So see you next time, world.